Hello, Glendale Community College. We are working on Chapter 13 and we are now up to our third video. We just finished doing some mass stoichiometry problems where we went from grams to moles, then used a mole ratio to get to the moles, and then back to grams. And that is great as long as we're dealing with solids and liquids. But what happens if you have a gas? Can you carry a gas and put it on the balance and get grams? No, it floats away. I mean, you can't weigh a gas just by putting it in your hands and carrying it somewhere because it's going to float away, obviously. So what do we do with a gas? Well, maybe we won't be given grams. Maybe instead we'll be given the volume of the gas. So look at this new chart. We are going to start on the far side with either grams if it's a solid and liquid, or with volume if it's a gas. So let's talk about the volume if it's a gas. If we're given volume of a gas, we still need to get to moles because we need to do the mole ratio, because this is all about stoichiometry, which is about doing a mole ratio. So do you remember 22.4 liters of gas is 1 mole of gas at STP. So we can use 22.4 liters in a mole for any gas to get to moles. Then we can do our mole ratio, moles to moles. And then depending on what we're finding, if it's a solid or liquid, we'll go back up to grams using molar mass. But if we're finding out about a gas, we'll go down and use 22.4 liters in a mole again to find out about that gas. So this is our complete chart. We can go grams to moles to moles to grams. We can go grams to moles to volume. We can go volume to moles to grams. We can go volume to moles to volume. We've already done grams to moles to grams twice. So let's try something else. First of all, here's a great question. Write and balance the reaction of hydrochloric acid with solid cadmium. That's a chapter 10 question. It's a great review. I want you to pause here and write out this reaction and think about what kind of reaction we're going to have between HCl and solid cadmium. I'll give you a hint. The metal's by itself. Okay, I hope you paused. I really do, and I hope you worked on that reaction. So we had HCl aqueous plus CD solid. A metal by itself? Metal by itself is probably going to be single replacement. So you went to your activity series. You looked up hydrogen and cadmium. Hydrogen is the least active, so it should be alone. Cadmium is more active, so it should be with a friend. Right now we have HCl together. Hydrogen has a friend in chlorine, but we just said hydrogen is less active, it should be alone. Cadmium should have the friend. We need CD and Cl to buddy up. Here's the reaction. It takes 2 HCl aqueous plus solid cadmium to make cadmium chloride. Notice the formula CdCl2. Because CD is a +2, you need 2 Cl's at -1 each to go with them. Remember to check your charges every time you put a metal and a non-metal together. You got to check your charges. And then hydrogen's left alone. Hydrogen is diatomic. Have no fear of ice cold beer. So we got our diatomic hydrogen. And because hydrogen, there's 2 of them, we need 2 HCl's. There's 2 Cl's, so it balances out. So that's the reaction. So I hope you are good at writing your own reactions, because you're going to have to continue to do that through the rest of the course. That was a single replacement reaction. Okay, so we got a balanced reaction. Let's look at our first question. How many liters of the gas? Which one's the gas? Oh, hydrogen's gas. So we got a chemical, hydrogen. At STP will form if 5.00 grams of cadmium, second chemical, reacts. We've got 2 chemicals. We got hydrogen, we got cadmium, we got a balanced reaction. It's stoichiometry. Stoichiometry means we're going to do a mole ratio. Let's go. Start with what we're given. What are we given? Well, 5.00 grams of cadmium. So let's start with that. Write that down. 5.00 grams of cadmium. To do a mole ratio, we need moles. We have grams. How do you go from grams to moles? That's right, our molar mass. What's the molar mass of cadmium? 112.41 grams per mole. Okay, so we've got 1 mole of cadmium on top. We've got the molar mass on the bottom. 112.41 grams on the bottom. Grams of cadmium cancel out. We're in the moles. Now we can do our mole ratio. What moles is on the bottom? Yeah, cadmium. How many cadmiums are there in the reaction? Just 1 mole. So 1 mole of cadmium's on the bottom. What are we trying to find? The gas hydrogen. How many hydrogens are in the reaction? Just 1. So 1 mole of hydrogen's on top. And moles of cadmium cancel. Now we have moles of hydrogen. Does it want moles of hydrogen? Look at the question. Wants liters. How many liters of the hydrogen gas? We need liters. How do you go from moles to liters? Well, if you don't remember, on the back of your periodic table, we have 1 mole of any gas. It's 22.4 liters at STP. So we got 22.4 liters over 1 mole of hydrogen. So the whole thing looks like this. So we got 5.00 grams of cadmium times 1 mole of cadmium over 112.41 grams of cadmium. Grams of cadmium cancel out. Then the next step is the mole ratio. We got 1 mole of hydrogen over 1 mole of cadmium, like we said. Say 1 to 1 mole ratio. Moles of cadmium cancel out. Then our last step is 22.4 liters of hydrogen over 1 mole of hydrogen. We got that from the back of our periodic table. 22.4 liters in a mole of gas. Moles of hydrogen cancel out. We're left with liters of hydrogen. When you put that into your calculator, you get 0.996 liters hydrogen, 3 sig figs. Because of the 5.00 and because of the 22.4, that only has 3 sig figs as well. So 22.4 counts in your sig figs as 3. All right, I want you to look at the next question. If 2.374 liters of hydrogen gas formed, so we got hydrogen gas again, how many grams of HCl reacted? We got HCl. We got 2 chemicals. We got a balanced reaction. We have a question. I want you to pause and try to work this one out on your own. All right, I hope you were able to work this one out. You start with 2.374 liters of hydrogen gas. There's our answer. We need to go from liters of gas to moles. Again, on the back of our periodic table, tells us there's 22.4 liters in a mole of gas at STP. So our first step is 1 mole of hydrogen over 22.4 liters of hydrogen. Liters of hydrogen cancel, we got moles. Now that we have moles, we can do our mole ratio, which is all about stoichiometry. That's what we're supposed to be doing with stoichiometry, is mole ratios. So on top, we're finding out about HCl. There are 2 HCl's in the reaction, so 2 moles of HCl's on top over 1 mole of hydrogen gas. There's only 1 H2 in this reaction. 1 mole of hydrogen gas. Moles of hydrogen gas cancel out. Now we've got moles of HCl, but it didn't ask for moles of HCl, it asked for grams. How do you go between grams and moles? Yeah, periodic table. So we got to add up an H and a Cl. So 1.01 plus 35.45. It's 36.46 grams of HCl in that 1 mole of HCl. Remember, a molar mass is always adding up one of them. 1 mole for a molar mass. One of them. 1 mole in a molar mass. Anyway, moles of HCl cancel out. We're left with grams of HCl. That's what we wanted. Yay! When you punch this into your calculator, you get 7.73 grams of HCl. All right, good job.